So there is 9.4. 9.4 is parabolas. Given what we're probably skipping in Algebra 2, you don't really need it. So, and it's kind of confusing. Do you want to learn about parabolas? Then you can come to study hall and learn about parabolas. Mm-hmm. Then you don't need to, because you don't want to. It's difficult.
Oh, no.
I just started this recording, and we started with the Drake equation. Starting chapter 10. Chapter 10. This is the start of it. It's all about our favorite shape, circles. Continuing with circles. So we already talked about what we know and what we wonder, right? Yes. Okay, so 10.1 is about arcs and sectors of a circle. That is it. What? Okay. So let's draw a circle.
I'll be coming around as we speak talking because I like to relax the ship. And nice circles on your page some people really care about. I got a bunch of washers. So I'll come around. Please just trim them in when you leave so that we can use them again tomorrow. Cool. I'll go and pass them out. There are two sides to choose from.
Mm-hmm. Okay, I'm gonna draw. What is my dot in my circle? Center. Okay. Center. Now I'm gonna draw a line. Draw it right here. What do we call that? Radius. I'm gonna draw two of these radius. Right from my center. Right there, radius. What do these two radius make? An angle, yes. And make an angle called theta. And that is going to be a very special thing. I'm going to put some labels on here. Wait a second. So we have A, B, my center, let's call it P. And I'm just going to make another point on this circle. Let's call it C. So go ahead, draw a nice circle, and label this right now. I just added points so we can call them special things. So draw my nice circle with two radius that make an angle. And label it as you have it in the picture. Arcs and sectors. So sectors. Got it? Yeah. Okay. So this theta is called a central angle. Is the angle formed by two radii. So that's a little theta. Yeah, in our picture. Got it? Theta. We have two radii. The angle in the middle is the central angle. Sonny, what's the question? This, see, you're gonna see in a second. We're gonna need it. Because if I say arc AB, do you know what I'm talking about? Yeah, what is it? The smaller one. We call that a minor arc. But yeah, but it could be the other way. But could be that. That's still from A to B, right? Eh, I would just go alphabetically. But this would be A, C, B. So this one right here, I'm gonna do the scratchy, is the smaller one. So that's called the minor arc. We're skipping around, but that's okay. So A, B is the smaller arc. And we call that the minor arc. A minor arc is just less than 180 degrees. Why 180 degrees? What is 180 degrees? Sort of. But what about my circle? If I do a straight line across my circle, I just made two semicircles. So it's smaller than a semicircle, or 180 degrees. So, semicircle. Now, if I have a minor arc, what might I also have? Major arc. Yep. I'm going to denote that with the bubble. So, this side. So that's why I need A and I need the C. So A, C, B. And if you see, my arc has an arc above it. So it's not a line, it's an arc. So make sure you're making that an arc above it. I'm going to make this one a little bit more clear. It's not a line, it's an arc. Ooh. Arc above. So AB is smaller than ACB. So this one is smaller than this gigantic one right here. So that's the arc made. So is larger than a semicircle, so called a major arc. So a major arc is always larger than a minor arc. What do these arcs add up to? Yes, 360 degrees. All the arcs should all add up to 360 degrees because the theta inside all add up to 360 degrees. So add up all arcs should equal 360. Any questions about vocab so far? Okay. I'll pick a new color. I'm scooching down. Okay, that's not there. Okay, the degree measure of arc AB is equal to the central angle of angle APB. So I'm going to draw my picture again. You don't need to because it's up above. Oops. So we have our two radius. We have the angle given right in between them. And if we're talking about the degree measure of this arch, it's going to be the same thing as our angle right there. So this is my measurement of AB. So the measurement of arc of AB is going to equal whatever our theta is, which is, in this case, in degrees. In degrees. Yeah? Want an example to play around with? Okay. I'm going to scooch down. Okay. Example. Yeah. Okay. So I will add my points again. So in your picture up above, P is my center. So I'm just telling you that A, P, B. So that's my angle. Telling you this angle right there. So that angle, which is theta. Okay. I'm going to give you a circle. Rogelia, give me an angle. Number in between 0 and 360. You're good.
25.
Okay. Ooh, nice and small. Okay, 25 degrees. That looks about 25 degrees. If this was 25 degrees, we'll call this A, P, B, and we'll put C out here so we can denote it. I want you guys to find the measurement of A, B, and the measurement of A, C, B. Okay? What is what? Yeah, I'm going to write it 25. 25. Oops. 25 degrees. Yeah.
While they're working, can I show you something handy?
Sure. Okay, talk to you about this. You want to pause it? Yeah. What? Yeah, 25. Riley, do you know why it's 25? Yeah, write 25. I would figure out how to write 25 in a second because it doesn't know how to write. Yep. So 25. What in the world? Okay, there we go. Now we can do it. Okay, so 25. Ignore that picture. Okay, ACB. I need to find first how much this entire angle is. How do I find this angle? Yep, which gives us how much? 335 degrees. Make sure we label that degrees. So if this entire angle is 335 degrees, what is my degree measure of ACB? Yeah, 335. Yep, it's equal to whatever this angle is. My degree measure of this arc is 335 degrees. That's not the length, it's the degree measure of this arc. We're about to do length and see how much that is. Cool? Okay.
That's it?
For right now, yeah. That's it for right now. That's the easy one. We're moving on to a harder one now. Yeah.
If it's me grading, and sweet comment, and I just want to stress that if it's me grading and you use 3 points for a minor arc, I will not give you credit. Just use why? Because 2 points is minor arc, 3 points is major. Notation matters.
Say it again?
If it like if we had a point delta between A and B on that example,
Yeah.
and they were talking about minor arc AGB, I would count wrong.
A.
If you put E between A and H,
Yeah.
like
Okay. Yes, yes, yes.
I would not count right if you said the measure of the minor arc is measured arc AGB. I'm ready after grading.
Yeah. So the angle, oops, the angle of this is APB. But my arc is A to B. This is my angle, yes, which equals 25 degrees. That's my angle. Yep. So the angle is talking about this right here, and my measurement, degree measure of this arc is talking about from here to here. Yeah, so two different things. Yep. So if I have 2 radius, this is my central angle. And this is my degree measure. Cool? Yeah? Okay. What is the length of a circle? How do we find the length of a circle? Or we don't really use the word length. We use something else. Circumference, yep. So we're going to do the arc length to circumference. To circumference. I will probably not spell out the entire word every single time because that was long. Okay. When we were doing our No One Wonder, do you remember what the circumference of a circle is? Pi is definitely in there. Yeah. 2 pi r is area. 2 pi r. Pi r squared is area. Okay, sorry. Area equals pi r squared. Circumference is this. If I did, I'm sorry. This is circumference.
What is that? 2x?
This is pi.
Oh.
Pi. It's okay. Sometimes you see it written like this. Sometimes it's written like this. I write it like this. If you see pi day over there, it's written differently too. That's the actual notation. You'll see it written either way. Depends on who is writing. Okay. We're talking about circumference. Arc length to circumference. So guess what? We're going to draw another circle. We're going to have so many of these on your page. Here is my circle. From my center, we're going to call... I'm going to draw my radius. Maybe.
If you click pencil and then back to pen.
Boom. I'm going to draw a radius. Ooh, radius. And I'm going to draw 2 of them so I can get my angle. Right there. How should I label the center? Okay, I'll put P down there. But this is an angle, right? Yeah, let's do... This is an... It's... Yeah, let's call it theta. And then up above, when I talk about A, and let's say B, this length right here, I'm going to call it S. An S. So S equals arc length. R is our radius. And theta is an angle. You may also see arc length as angle measure, but we're going to stick with arc length for a bit. Now, theta. How many degrees on a circle? Okay. I'm going to write this as a ratio. R theta will be a percent or a portion of this 360 degrees, right? Yeah, it's going to be a portion of it. Not all of it, but part of it. I'm going to keep using theta. I like theta. Yeah? Okay. So, and my arc length is a part of my circumference, right? Yeah? Okay. So, S is part of my circumference, which is 2 pi r. I'm going to set these two equal to each other. So if I talk about the entire circle, which is down below, the entire circumference is 2 pi r, which is also how many degrees, Jonah? Entire circle has how many degrees? Yep, 360. So that's why they're both on the bottom. So that's a full circle.
theta over 360, right?
Yeah. Now, above it is the part that we're talking about. We're talking about this area right over here. We want to know the arc length of this. So this is part of the whole equals theta divided by 360. Now, if I want to talk about arc length, what is arc length in this problem? Which letter? S. So if I get S all by itself, what do I have to do? Pi. Yep. 2 pi r on both sides. So my arc length equals theta divided by 360 times 2 pi r. Now, for our sake, we're not going to talk about radians yet in this class. Algebra kids, you're going to see radians very soon. But we're just going to talk about degrees. That's it, other circles. So instead of using theta, we can also write this as S equals any number of degrees, we don't know, whatever theta turns out to be, whatever they give us, divided by 360 times 2 pi r. So that's my equation that gets me arc length. So this is arc length. Want to do some... Okay, do you want to do brain break or do you want to do problems on the boards first? Okay, that's fair.
Yes.
It's a lot. It got really quiet. Okay, do you want to do a board problem or you want to do one together? Really? Okay, challenging one it is. Okay. 6 groups. 1, 2, 3, 7 groups. Count.
Dos. Oh, sorry. Oh, 2. Wait. 4.
4. Lord.
No.
Let's do this again. 1, 2, 3, 4.
Oh. 2.
That's 2, 3, 4, 5, 6, 7, 1.
Okay, get up in your boots. Tom will be on the board in a minute.
No, we got, huh?
Dos.
Who's 2? Who? Are you 6? 2? Sonny? 2? No. 2's back there.
What? No. Sorry. You can erase that. Yes. Okay, sketch the circle on your board.
I'm gonna sketch in the world. Sketch for me. Which this one?
Oh, this is not that one. I don't know yet. Well, I do know, but I'm still drawing it. Oh, not that one. Draw it as I'm drawing it, because I have to still write it. W, X, Y,
43.
Z. This point in the middle is P.
104, okay, so 73, 73, and then 104.
Yeah. Yes. Because I'm still writing. Find length
7.
W, X.
Why is there 7?
Is that a 7? B equals 2.0. Oh.
There you
I did the math.
That's gonna be the last one. Find. We're gonna find something first. Find measurement of WX.
Well, it's like my.
Of course. I don't know, I feel like if I like ask for help, it's like if I like if I don't use a notebook, I feel like low IQ. What? Sound like
Sonny,
what?
you can use your notebook.
I just don't like it. I don't know why. I just feel more useless without it. I wasn't with it. I don't know. I feel useless.
S over 2 pi r. 2. The circle with the line through it. And 3/16.
Oh, that's what that.
This might be the end of this book.
Oh, can we just like start here? Where do we need to put all this?
Okay, you need to find this. These two things are not the same. This. Wait, it doesn't work. It doesn't make this. This is degree measure. This is the length. These are two different things.
WX is the 7 degree.
The degree measure, yes, and then the length is something else.
Wait, for the first one though, that's the answer.
For